Good day, ma'am. I'm April Joy Songay, BSed Math 1A, and this is my micro teaching or demo for your subject. And please excuse me for the background noises when I'm doing the video. Please enjoy watching and I hope you like it. Thank you. Okay, good day everyone. I'm teacher April Joy Songay. You can call me Ma'am April, Ma'am AJ, or Teacher Joy. And I will be your teacher for today's lesson in your subject, Statistics and Probability. And I have rules and regulations in today's lesson as your teacher. First, quiet and listen to me when I'm discussing in front. Second, eyes on me when I'm discussing the lesson. Third, put your cell phones on vibrate mode. And the last is, don't hesitate to ask me when you don't understand the lesson. Are we clear? Okay, good. So everyone, please stand up for our prayer. So who wants to lead our prayer? Anyone? Yes. What is your name? Micah. What a beautiful name, just like you. So, Micah, please lead us to our prayer. Amen. So everyone, please sit down and thank you, Micah. So before we start, is anyone absent? Okay, very good. Perfect attendance. So before we start, who can remember the previous lesson by your teacher in this subject? Okay, what is your name? James. So what is it, James? About random variable. Okay, very good. Who else? Yes? What is your name? Marian. Okay, Marian, what is it? About discrete random variable and continuous random variable. Very good. So who else? Anyone? Yes, what is your name? Jenny. Okay, Jenny, what is it? About the probability distribution or probability mass function. Okay, very good, Jenny. And the last is, yes? Yes, Joanna? Right, Joanna? Okay, what is it, Joanna? About the mean, variance, standard deviation, and mode. So, very good, everyone. You listen to your teacher on your previous lesson. So, before we start, I prepare this as an energizer for you to have an idea on what is our lesson for today. So everyone, did you know the song? Oh, it's math time after all. Okay, very good. So you're going to do is we will sing oh it's math time after all when and you will pass this by your seatmate when we are singing, then when it stops you will answer the question. So are we clear? Okay, very good. Here, so let's start. Oh, it's math time after all. Oh, it's math time after all. Oh, it's math time after all. Come together and come on. Okay, what is your name? Jeka. Okay, Jeka. First question. It is distribution that consists of a very large number of cases and the three measures of average, which is mean, median, and mode, are equal. Then the distribution is symmetrical and the skewness is 0. So what is it? Okay, very good. Normal distribution. Okay, we'll find the normal distribution. Okay, here. Normal distribution. Very good. Okay, start. Oh, it's math time after all. Oh, it's math time after all. Oh, it's math time after all. Come together and come all. Okay, James. So, what is the table of areas under the normal curve? It's also known as Z table. Very good. Z table, where are you? Okay, here, Z table. Okay, start. Oh, it's math time after all. Oh, it's math time after all. Oh, it's math time after all. Come together and come on. Okay, what is your name? Jane. Okay, Jane. It represents the distance between a given measurement, x, and the mean expressed in standard deviation. What is it? Okay, very good. Z score. Okay, Z score here. Okay, very good. Okay, Oh, it's math time after all. Oh, it's math time after all. Oh, it's math time after all. Come together and come on. Okay? Leia. What is it? Bell shape. Very good. Bell shape. Okay. Bell shape here. Very good, Leia. And the last is, oh, it's math time after all. Oh, it's math time after all. Oh, it's math time after all. Come together and come on. Okay, Mika. What do you call this? What do you call this sign? Okay, very good. Normal probability distribution. Where is normal probability distribution? Okay, here. Normal probability distribution. So, very good, everyone. So, now do you have an idea what is the lesson? What is our lesson for today? Yes? It is about normal distribution. Normal Chapter 3 normal distribution, but we are going to proceed on the lesson 1, which is okay. Lesson 1. Lesson 1 here pala. Ito na lang. I really need this new hand. Okay. Our lesson today is Chapter 2, Normal Distribution, Lesson 1, Understanding the normal curves. So, in this lesson, you will understand the concept of the normal curve distribution, also state and illustrate the properties of a normal curve distribution, and you will able to know how to sketch the graph of a normal distribution, and you can recognize the importance of the normal curve in statistical inference. Okay. So in this lesson, we have 5 parts. First, visualizing a frequency distribution. Second, no, it's four parts, but I will add the fifth. Then second is visualizing a normal distribution. Then third is visualizing, and then third is stating the properties of normal probability distribution. The fourth is understanding the standard normal curve. And the last is exploring the graph of a standard normal curve. Exploring the graph of a standard normal curve. Okay. So, in the previous lesson, we used graphs and sample of discrete data to find probability distribution with the same shape or pattern. The pattern is used to calculate probabilities of a population that will enable us to make prediction or decision concerning the population. However, certain data are of the continuous type. In this chapter, we will consider a distribution of this type. The distribution is commonly known as normal probability distribution. Remember that. Or simply the normal curve. So, I'm visualizing. So first part is visualizing so the first part is visualizing a frequency distribution. So a frequency distribution shows how often each different values in a set of data occurs. So mostly in visualizing a frequency distribution, we use histogram. It is the most widely used technique to visualize frequency distribution. So anyone who knows what do you think the histogram is? Ganito. Ganyan. Yan. For example, yan. Gawin natin yung example niya. So, yung score niya is 21, 20, 19, 18, 17, 16, 15. Then, ito yung frequency. Then, dito natin ilagay sa ilalim yung score, which is from 15, 16, 17, 18, 19, 20, 21. Then, dito sa atas is from 1, 2, 3, 4, 5, 6, 7, 8, so on, so on, so on. So, 15, we have 1. Then, 16, we have 3. Okay, 17, we have 6. Okay. Then, 18, we have 11. 18, we have 11. Again. So 19 we have 7. Then 20 we have 5. 21, we have 2. Okay, ganyan yung histogram. Ganyan din yung paglagay natin ng score kung gagawa tayo ng histogram. Okay? Understand? Okay, very good. So now we will proceed to our next part of the lesson. First part of our lesson, which is visualizing a normal curve and normal distribution rather. Sorry. Oh my God, it's hard to find this stuff. Just wait. Sorry. Okay, the visualizing frequency and the visualizing normal distribution. So you can see, visualizing a normal distribution, modes of the scores will be found between these two extreme scores. In reality, if a distribution consists of a very large number of cases and 3 measures of average, mean, median, and mode are equal, then the distribution is symmetrical. Symmetrical means balance. And the skewness is 0. The skewness is asymmetrical or not balanced. In statistics, such as distribution is called normal distribution or simply normal curve. So that is the visualizing a normal distribution. Then the next part of this lesson. Okay? Do you understand pala? Okay, very good. Remember, don't hesitate to ask me when you don't understand what I'm saying. Okay, stating the properties of the normal probability distribution, which are, number 1, it is bell shape. So, bell shape daw, ganito yan. The distribution curve is bell shape. Ganyan. 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 Then, second, the curve is symmetrical about its center. So, balance dapat from center to side by side. Then, third, the mean and the median and the mode coincide at the center. So, the mean and median and mode they occupy the center. Dito sila sa loob. Then, the width of the curve is determined by the standard deviation of the distribution. So, dito yung nakabase kung gano'ng kalapad kasi dito yung standard deviation sa gitna. Then the tails of the curve fallen out and indefinitely along the horizontal axis, always approaching the axis but never touching it. So di dapat daw touch yung 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 last ng ating bell shape. That is, the curve is asymptotic to the baseline. Asymptotic means di nga daw siya nag-touch. Then, our fourth part of the lesson is understanding the standard normal curve. So, understanding the standard normal curve. Okay, do you understand what I'm saying? Again, may I ask? Okay, thank you. Okay, understanding the standard normal curve. Okay, do you see? You can see what I'm posting in this wall. Okay, understanding the standard normal curve. The standard normal curve is a normal probability distribution that is most commonly used as a model of inferential statistics. So, what is inferential statistics? Is the process of using data analysis to infer properties of an underlying distribution of probability. Also, it is the analysis that infers properties of a population. Example is testing hypothesis. So, the equation of that describes a normal curve is this, where y represent the height of the curve values of x. Then x represent the any scores of the distribution. Then this sign is represent the standard deviation of the population. This one is represent the mean of the population. And do you think what do you think this one? Okay, pi. How about this one? The E constant or the Euler's constant. Okay, very good. So, I'm going to teach you how to solve this equation. So, for example, our x is 4, then our standard deviation is 2, and the mean is 6. So, y is equal to e 1/2 the value of x, which is 4, minus the value of mean, which is 6, over the value of standard deviation 2 raised to the power of 2 over the value of standard deviation 2, then 2 the value of The value of A pala is 2.7183. Value ng E. And then the value of pi, which is 3.1416. So we're going to solve this. So anyone can please get their calculator and try to solve this problem. If you can. Okay, let's start. Four minus 6 is equals to negative 2 over 2. This is the power of 2. One point 6489. Ayan. Then the 2 times 3.1416 is equals to 6.2832. So again, we'll solve 1.6489 negative 2 is the power of 2. So we have 1. Then 2, 6.283. We have 5.013. 0132. And 1.648 million times, then we have 1.648 over 5.0132. Then the answer is 1.64895.013. Then the answer is we have 0.32 89. So this is 89. So this is the value of y. Are we clear? Okay, very good. So let's proceed to the next part of our lesson, which is oh, oh the continuous part of understanding normal curve. So the continuous of the understanding standard normal curve, which is the table of errors under the normal curve, is also known as the z-table. The z-scores measure a relative standing. It is calculated by subtracting the mean from the measurement x and then dividing the result by the standard deviation. Then the final result, the z-score, represents the distance between a given measurement x and the mean expressed in standard deviation. Either the z-score locate x within a sample or within a population. So I will show you the z-table. So this is the z-table. So, but I will show the half because I can't reach the very height of this. I'll show you this one. The half of z-table. Because I can't reach the top. And no one is helping me. It's okay. I can do this on my own. Just focus on studying our lesson. So, but I will ask you first, do you understand our lesson? Okay. Okay, I can reach the top. So, and I can even and I take out my phone because the scotch tape is falling. So this is the z-table. So but I will show you the whole copy of C table later, but I'm going to put it on the paper, or we could print it. Or do you think, or is anyone, do you have a book of this statistic and probability? Because on page 55, we can see that there the Z table, or the table areas under the normal curve. So this is the table areas under the normal curve. So then this is, so we have 4 steps in processing to find the areas under the normal curve. So for example, we have the find the area that corresponds to Z equals 1. So Z was 1.00. So yan. Then in the table, we find the row 1. Row 1 here. Ito yung row 1. Then in the table, find the call. Ito yung hanapin, 0.10 sa row. Ito yung row. Ganyan, pa ganyan. Then ito sa row to. Then ito sa column. Sa column. Ito naman yung column. Pataas, ito baba. So 1.0 is, ito yung 0.00. Then we will have the 3, 4, 1, 3. So do you understand when we are finding the area that correspond on the Z? Okay, very good. So let's proceed to the last part of the lesson. So we have, what is the last part of the lesson? We have the, what is it? So anyone? Ano ngayon kanina? Okay, exploring the graph of a standard normal curve. Very good. Sino yung sumagot? Okay, si Mika. Okay, Mika, very good. You listen to my discussion very well. Ito na yung last. The 4. Ito na yung last. The 4. Ito yung last. Exploring the graph of standard normal curve. Ito yung 4-step process in finding the areas under the normal curve. So, yun yung sabi. Express the given Z value. Ito 3-digit. Ito 3-digit. Then, using the Z table, find the first 2 digits on the left. Ito nga, yung row. Then, yung isa is 4 column. Then, match the third digit with the appropriate column on the right. Yung ginawa ko kanina, yung 1 point, yung 1.0, then ito yung 0 to 0 is 3, 4, 1. Then, if you're going to read the area of the probability is, we should say, the area is, hindi pala siya 3.14, 0.3413. So we will read it by this area is 0.3413. This is the required area. Ganun yung pagbasa natin. Then, exploring the graph of a standard normal curve is, the normal curve. The normal curve for a population distribution is specially determined by its mean equal to 0 and the standard deviation equal to 1. The horizontal base contains the z-score values associated with under the curve and handy model of a normal curve made by cardboard cardboard is a useful learning tool. So, ito yung graph ng normal standard curve. Dito, makikita natin yung standard deviation, which is the population. Diyan yung standard deviation sa gitna. Then, itong side by side is points of inflection. So what is what is the points of inflection? Those are the points where the function changes. So kaya pa ganyan yung sign ng standard normal curve is para malaman natin yung changes ng ating population. Being concave up or pataas or di kaya pababa or vice versa. So, ganyan yung graph of standard normal curve when we are graphing the standard normal distribution. In the next lesson, you will able to know how to graph the standard normal curve by each problem. So, anyone, do you understand? So everyone, do you have questions on our lessons? Okay, none. So I will end our discussion here, and I hope that you learn something from me or something on my discussion, and you will be able to use it on the future of in the next lesson. That's all, and that's all, everyone. Thank you.